We're going to get into section 6-3 over hyperbolas. This is the last conic section that we will talk about. And yeah, move on. So I'm going to go through some of these slides pretty quick, so you can either pause it and take a look at the stuff, or glance at the PowerPoint that's on Canvas to catch up on some of the words and definitions that I'm talking about here. But our kind of objective here, look at the equations of hyperbolas, graph hyperbolas with a center of 0, 0. Again, that's not changing. This was a cool link that no longer works. I need to take that off the PowerPoint. But here's hyperbolas. So I know this looks like two parabolas, but it is actually much, much closer related to ellipses than it is to parabolas. So a set of all points in a plane that are the absolute value of the difference of the distances from two fixed points is constant. Two fixed points are called foci. So just like we had with ellipses where we had two foci, we have two foci with these hyperbolas. So what we can say again, this distance 2 minus distance 1, the absolute value of that, or distance 1 minus distance 2, that would be constant. But again, we'll get into the same stuff we did before, writing equations and all that. There's different positions. There is the one that goes to the right, opens left and right. Here is all the information about one that opens left and right. I'll keep that. Here's one that opens up and down. And same thing. Here is all the information of one that opens up and down. Sorry, I keep moving this thing around. We have the transverse axis. That's essentially going to be what we call it, as it equates to the major axis of an ellipse. The conjugate axis that equates to the minor axis. Those are parentheses. A lot of stuff is similar. What's new is these last two things. We're looking to talk about the asymptotes, and then we're going to talk find c squared, a squared plus b squared. So there is the Pythagorean theorem. A squared is always under the positive fraction. It's not bigger anymore. It's always under the positive fraction. And here is, again, some more information. A goes with the transverse axis. B goes with the conjugate axis. Again, major, minor. A squared is always C squared, equals A squared plus B squared. No size relationship between A and B. They could be the same. B can be bigger. It does not matter. A is always underneath the positive fraction. There's a wrap-up of everything. Is centered at HK. That's clearly where we're headed with the this, just like we did on all of our other conic sections. So that's where we're going. This is where we're at. Kind of wrap up things. Everything. These asymptote equations are what I'll talk about here momentarily as well when we get into the graph. So just like we've done before, this is everything I'm looking for. Vertices, co-vertices, these are, we'll kind of talk about the conjugate axis vertices, co-vertices. They're not really part of the hyperbola, but I'll get into those. Foci, length, transverse conjugate axis, equations of the asymptotes, and we'll graph it. So just as we have always done, we need to make sure this is equal to 1. If it's not, this is not in this case. So we need to, just like all the other ones, divide by what that number is. In this case, 144. And when I do that, I get the following. I get x squared over 16 minus y squared over 9 conveniently equals 1. So there's my equation. So the things we're looking for, I think I went back, nope, is highlight some of this stuff. Give me 1 second. Well, no, it's not going back. There it's going back. So vertices, co-vertices, foci, all that other stuff. So the first thing we'll look for is the vertices. And what goes with a vertice, or again, I guess we can talk about being 0, 0 as well. So the center of this is going to be 0, 0. That's not going to change for right now. There's no h and k up here. Our center is 0, 0. So we have to identify what's a and b. A is always positive. A squared goes with what is positive. So a squared, in this case, equals 16. A equals 4. B squared equals 9. That's the other one, the non-positive fraction. There's negative in front of that one. B squared equals 9. B equals 3. So now our vertices, we have to talk about this being left and right. This is left and right because the x is squared. So whatever one is positive, that tells you the direction. So x is squared, we're going to go left and right. Left and right 4 units. 1, 2, 3, 4. 1, 2, 3, 4. If I want left and right 4 units, I'm going to go up and down 3 units. 1, 2, 3. 1, 2, 3. So we have our vertices that we're going to look for. We have our co-vertices we're looking for. We have our foci that we're going to look for. So our vertices, again, this is a horizontal. This right here, left and right, this could be. These are going to be our vertices. Since the center is at 0, 0, this is plus or minus 4, 0. Those are our vertices. Our co-vertices, if we went left and right for our vertices, we're going to go up and down for our co-vertices. 0 plus or minus 3. Again, very similar to the ellipses, opposites of each other. Now this next thing I'm going to add a box around. I'm going to add a box around all these points. That's a square. I don't want a square. I want a rectangle. I'm even going to make it dashed. So there is my box. And I'll explain what that means here in a second. So our foci now, just like the foci on an ellipse, go on the transverse axis, go on the major axis. That goes with c squared. So c squared in this case, different from ellipses. C squared equals a squared plus b squared. C squared equals 16 plus 9. C squared equals 25. C equals 5. Again, those go on the transverse axis, which equates to the major axis. There's 4, there's 5, there's 4, there's 5. So there's a focus, there's a co-vertice, there's a vertice, there's the center. So we're almost ready to fully graph this and add the parabola-looking shapes. But the last thing we need is the equations of the asymptotes. So this is a horizontal one. Here's the equation of an asymptote for a horizontal hyperbola. Y minus k equals plus or minus, the key here is b over a times x minus h. Now if you don't remember, that's not a problem, because again, this box is going to help us out. The asymptotes go through the corners of this box. And so I can go ahead and graph our asymptotes. I'll make this dotted or dashed as well. That's way off. There's one asymptote. Notice what it does. It goes through the center and goes through the corner of the box. The other one looks right there. Those are the asymptotes. So once I have the asymptotes, I can sketch my graph, but I need the equation of this asymptote. So the key is where the center is 0, 0. That's easy enough. But what we need to know is what the slope is. So if you don't remember this back here, if you don't remember it's horizontal, it's always b over a, what you can do is count. So I'm going to count up 1, 2, 3, that's rise. 1, 2, 3, 4, that's my run. So the slope, we went up 3 over 4. Or I can do this, I can go down 3, 1, 2, 3, 1, 2, 3, 4, down 3 over 4. So it turns into a plus or minus 3/4, which turns into, as we look here, plus or minus b over a. So again, if you don't remember this from the kind of a little formula, just recognize you can count to these corners of this box. That's why those boxes are so important, that I will add to all of my hyperbolas. So there's the slope. Now let's write our equation. Our equation of the asymptotes, in y minus k, y minus 0, equals plus or minus b over a plus or minus 3/4 x. And And that goes right through the origin so that we know that's what it looks like. I need to add my foci over here. My foci are going to be plus or minus 5, 0. Notice our foci look just like our major axis vertices. So we can go ahead and add our actual hyperbola in now. So here's, again, you know, it hugs the asymptotes. That's why the asymptotes are there, to give it some shape. So there's what that graph looks like. So again, the hyperbola goes through the vertex, not the focus. So make sure you put it through the vertex and not the actual focus. So that's graph, and that's everything we're going to look for. Oh, I didn't do the lengths here. I'm sorry about that. So the length of the transverse axis, that is 2a, so that is going to be 8. That's really messy. Sorry about that. Conjugate length is 2b. That is 6. So 2a, 2b. That's the same as it is for the ellipse with the major and minor lengths. So let's write an equation or two real quick. This time we're given the foci are at 6, 1 and 2, 1. Vertices at 3, 1 and 5, 1. So again, as always, I'm not going to grade this. I think it's helpful to plot. So 2, 1 is right here. 6, 1 is right there. That's a focus. That's a focus. Vertices are at 3, 1 and 5, 1. There is 3, 1. There is 5, 1. So, as always, things we need when we're writing equations: we need the direction, we need the center, and just like ellipses, we need A, B, and possibly C. So direction, if foci are left and right, we know the direction is going to be horizontal. Our center, again, the distance between the two foci, the distance between these vertices, we can count, we can find the midpoints of that. There's our center right there. 1, 2, 3, 4, up 1. Our center is 4, 1. Notice 4 is the halfway point between 2 and 6. 4 is the middle between 3 and 5. Hopefully you're getting familiar with finding that for our center. These are vertices. Those are if it just says vertices, that means they're the transverse axis vertices. That means they're the major axis vertices type thing. So our distance between here is A. A is 1. Our distance between the focus and that center is C. C is 2. So our equation now of one that opens left and right is going to be this. We have left and right, so x, I'm always going to put my positive fraction first, x minus k, x minus h, oh man, x minus h squared over a squared minus y minus k squared over b squared equals 1. We have our center, we have our a value, we can find a lot of this out, fill in a lot of this. So it's going to be x minus 4 squared over a squared. A is 1, so over 1 minus y minus k squared, y minus 1 squared over b squared, which we don't know what it is yet, equals 1. So just as we've done before, we have a, we have c, we can find out what b is. In this case, it's going to be c squared equals a squared plus b squared, or equals 1 plus b squared equals 3. Just as before, we don't need b necessarily if we have b squared. B is 3 in this case. And there is our equation. Let's see, this last one, another equation, vertices at 2, -8 and 2, -2. So here's 2, -2. Here's 2, -8. Vertex, vertex. So now we can tell that this goes up and down. So the equation of a parabola that goes up and down is going to be, I'm sorry, hyperbola, excuse me, is going to be y minus k squared over a squared. Again, I put the y first, still over a squared, minus x minus h squared over b squared equals 1. So our important information, our direction, our center, and A, B, and C. So our direction is vertical, because those are vertices, those are major vertices, those are transverse axis vertices. So it's up and down, that's vertical. Our center, we can find the midpoint here. We know this distance is 6. 6 equals 2a. A equals 3. So I can count down 1, 2, 3, and find my center at -2, -2, -5. A is 3. Up here we say our conjugate axis length is 24. This is the same as 2b. So the conjugate axis length is 2b. 2b is 24. B equals 12. So notice B is bigger here, but that doesn't matter to us in our equation. We're fine with that. So our final answer here, our final equation is going to be y plus 5 squared over a squared, which is 9, minus x plus 2 squared over 144 equals 1. So there's a couple writing equations. There's the intro to graphing. Sorry, this is a little longer video, but thanks for watching. As always, subscribe and stay up to date on your freshest Algebra 2 Honors content. Talk to you soon.